In this sequence of videos, we're going to discuss right triangle trigonometry and the law of cosines. These are two related but different topics. So let's talk about an overview of both of them briefly. So with right triangle trigonometry, what we're going to do is we're going to take the trigonometric functions that we've discussed beforehand, things like sine of t, cosine t, tan t, etc. And currently we know how these are defined in terms of a unit circle. We'll show that we can also use these in the context of right triangles, and we'll see how we can use them in order to determine useful information such as lengths of sides of triangles and measurements of angles of triangles. We'll see when we start out that we can only use these techniques for when a triangle is a right triangle. However, after we've discussed how to apply the trigonometric functions to a right triangle, we will apply them to some types of triangles which are not right triangles using what's called the law of cosines. So we'll see how to adapt the usage of these trigonometric functions to not only determine useful information about right triangles, which I have drawn right here, this is a right triangle, but also some triangles which are not right triangles. Okay, let's begin. And we'll start out talking about right triangle trigonometry. So here I have a circle drawn and a triangle drawn inside it. Now for the moment, let's assume that this is the unit circle so that this length here would be 1. Remember, the unit circle has radius 1, and that side that I've labeled 1 has length equal to the radius. Let's go ahead and call this angle here t, which we've drawn a little bit differently in this drawing here. Normally what we see is we see a ray like this and a ray like this, and we say that this is in standard position. Or perhaps better said, t is this angle in standard position. For now, let's keep these rays here and have an angle drawn as we used to draw them, but I may erase them in a moment. And let's go ahead and label the terminal point. The terminal point for this angle is this x comma y point. And we know for this drawing that I've drawn, that is, I have a unit circle, I have an angle in standard position, and I have labeled this angle t, that sine of t is going to be y, and I'm going to write this as y divided by 1, and we'll see why I've done that in a moment. Cosine of t is x over 1. Again, we had just written it as x before, but I'm going to write it as x over 1, and then tangent of t is y over x. So far none of this is new except I've drawn a triangle, specifically a right triangle, in my drawing of this angle. I do want to make some observations about the lengths of this triangle. So this x is the x-coordinate, that's going to be this length here, this horizontal side of my triangle. Then y is going to be the length of this vertical side of my triangle. And of course, if we're on the unit circle, then the hypotenuse of this triangle, the hypotenuse is the long side that is opposite of the right angle. That length is going to be 1. So now I have this triangle drawn inside the unit circle, and I have my trigonometric functions written down, but I don't need the unit circle in order to draw the triangle that I have here. That is, if I erase everything about the unit circle here, then my drawing still makes sense. And what that means is, if I have a triangle and this length is x, this length is y, and this length is 1, then I can define sine of this angle t to be y over 1. I can define cosine of this angle t to be x over 1. and I can define tangent of t to be y over x. So I can define all of my trigonometric functions in terms of this triangle here. However, a pretty severe restriction is that this hypotenuse is 1. We'd like to be able to define the trigonometric functions when the hypotenuse could be any length. So let's go ahead and replace this 1 with an r, and we'll go ahead and replace in the definitions of the trigonometric functions the 1 in the denominator by an r as well. And what we're left with here are the definitions of the trigonometric functions. These are the definitions of the trigonometric functions of a right triangle. It is extremely important that your triangle is right. So if your triangle looks like this and does not have a right angle, then you can't use the trigonometric functions yet for this type of triangle. But if you have a right triangle, then these are the definitions. Now, very frequently there's some terminology associated with right triangles, and then from that terminology we typically write these definitions in a slightly different way. So for the triangle that I have drawn here with this angle t given, we say x is the length of the leg adjacent to t. So the leg of the triangle is this horizontal side. And frequently we just abbreviate this length x with the letters A, D, J for adjacent. For y, we typically abbreviate that OPP. It is the length of the leg opposite to t. And now the legs of a right triangle, those are the sides which have the shorter length. R here is the length of what's called the hypotenuse. Hypotenuse. And it's frequently abbreviated HYP. So using these abbreviations, we can rewrite y over r as OPP over HYP, opposite over hypotenuse. Cosine of t is going to be adjacent over hypotenuse, and tangent of t is opposite over adjacent. And certainly this deserves its own slide, so let's go ahead and do that, perhaps without so much clutter. So here's my right triangle, and I've relabeled t as alpha because typically when talking about angles in triangles, either Greek letters, lowercase Greek letters are used, or uppercase Roman letters are used. I will prefer to use lowercase Greek letters such as alpha, beta, gamma, theta, and phi, which I will write like this. So in this triangle, sine alpha is opposite over hypotenuse. Cosine alpha is adjacent over hypotenuse. Tan alpha is opposite over adjacent. And we can define the reciprocal of sine alpha as well. Remember, that is cosecant. So cosecant alpha, that's defined to be the hypotenuse over opposite. Secant alpha is defined to be hypotenuse over adjacent. And cotan alpha, which I think I'll have to write over here, that is adjacent over hypotenuse.